Assalamu alaikum dear students. Today we are going to discuss the remaining part of the alkyl halide. In last lecture of alkyl halide, I have given a discussion on preparation, nomenclature, types of alkyl halide. Now we are going to focus on the chemical reactions. What are the chemical reactions of alkyl halides? If you are going to discuss the chemical reactions, there are two types of the chemical reaction. One is the nucleophilic substitution reaction. Second one is the elimination reaction. What is the nucleophilic substitution reaction? What is the substitution reaction? The replacement of one atom or group of atom by another atom is called as the substitution reaction. For example, here is the alkyl halide. If you have replaced the halogen group X group with other atom or a group of atom, this is called as the substitution reaction. Now the question raises why it is called the nucleophilic substitution reaction. It means replacement of the halide ion X ion by an other strong nucleophile is called as the nucleophilic substitution reaction. Now, because here, if you look at this alkyl halide Rx, halide ion is also a nucleophile, but this nucleophile replaced with another nucleophile, then this is called as the nucleophilic substitution reaction. Before discussion on the nucleophilic substitution reaction, what is the nucleophile? Nucleophile is basically a species. Nucleus, nucleophile. Nucleus, phile means loving. Nucleo means nucleus, phile means loving. Nucleus loving. It means it attracts the positive body, and almost it contains the negative charge. So nucleophile is the species, you can say, is the nucleus loving. It's the species that contains the unshared pair of the electron or a negative charge. So nucleophile, which is rich in electrons and attracts and loves the nucleus body. I think you understand what is the nucleophile. Nucleus loving, which has the negative charge or a pair of electron. It means it rich an electron and attached towards the positive body. This is called as the nucleophile. And what are the basically nucleophile? If I'm going to give the example, there are two types of the nucleophiles. Number one, which contains the negative charge, for example, OH, hydroxide ion, ethoxide ion, cyanide ion. Some are actually the neutral, just like water, ammonia, but the nitrogen and oxygen contains the lone pair of electron. That's why they are called as the nucleophile, because they are rich in electrons. Second most important thing is the one is the nucleophile. Second is the opposite of nucleophile is the electrophile. Electron loving. It means any atom which has the deficient of electrons and electron loving and attracts the electron is called as the electrophile. Third is the three things in the nucleophilic substitution reaction participate. This is the general reaction of nucleophile, which is on the screen. For example, this is the alkyl halide. CH3Br is the alkyl halide. OH negative is the nucleophile, and when the nucleophile attacks on the alkyl halide, this nucleophile replace the bromide, and bromide leave out with its electron pair. This is called the halide. So you can say when another nucleophile, which is stronger than a Br of alkyl halide, attacks on the alkyl halide, Br leave. Br leave and hydroxyl takes the place of the Br and forms the methyl alcohol, and bromide with its electron pair leave out. So what are the three main things participating in the So in the nucleophilic substitution reaction, three are participants. One is here nucleophile, attacking body, alkyl halide, that is called here is substrate, and bromide, that is replaced, that is called as the leaving group. So three are the participants: leaving group, nucleophile, and the alkyl halide substrate. I have told you about the nucleophile. Nucleophile is basically what? Nucleophile is the negatively charged body or neutral with a lone pair of electrons. And substrate is what? Alkyl halide, RX. As you know, we are discussing the reactions of alkyl halide. Third one is the leaving group, that is the part of the alkyl halide. And what is the electrophilic center? Electron deficient center is the R. R is the electron deficient center because due to the difference of this polarity, look at here, bromide is more electron negative than carbon, so some polarity develops. So this is highly electronegative and this carbon is positive charge. That's why this nucleophile attacks on the electrophilic carbon, electron deficient carbon. As a result of this, leaving group leave out. How many types of the nucleophilic substitution reactions are there? There are two types of the nucleophilic substitution reactions. I think you are going to clear this. It's clear for you, replacement of one nucleophile with other nucleophile. Two types of the nucleophilic substitution reactions are there, SN2 and SN1. S shows substitution, N shows the nucleophilic, and number 2 I will tell you later why it is called the SN2 and why it is called as the SN1. So following up the steps of the nucleophilic substitution reaction SN2. Here is the alkyl halide. It mostly used for the primary alkyl halide. You know, the carbon which is attached with the halogen group and further attached with one carbon atom or a hydrogen atom is called as the primary alkyl halide. The SN2 primary alkyl halide follows always the SN2 nucleophilic substitution reaction. What happened? Hydroxyl OH negative attacks on the carbon and the same time bromide leave out. A transition state is formed in which at the same time hydroxyl group makes a bond with the carbon and carbon Br bond is breaking. And after the next step, this bromide with its electron pair replaced with the hydroxyl group attached with this alkyl halide group. So what is the most important thing? This is a simultaneous reaction. At the same time, bond formation between the hydroxyl group and carbon takes place in the transition state, and at the same time carbon bromide bond is break. So this is these reactions are taking place at the same time. You can say bond formation with the hydroxyl and bond breaking with the bromide takes place at the same time, and bromide with this electron pair leave out. This is called as SN2 mechanism. Because why? First is this is the following other points. Number 1 point, it's a single step reactions. Hydroxyl group attacks on the same side and bromide same reaction, same step, and the bromide leave out in the same step. So it's a single step reactions. No intermediate stage is formed. Here is particular transition state is formed where the bond breaking and the bond formation takes place at the same time. Now, what happened to there? This is the 2 points are very important. Rate of the reaction. First of all, I will discuss the rate of the reaction. Rate of the reactions in the first year class, you have in chapter kinetics, 2 terms I have told you. One is the order of the reaction and molecularity of the reaction. Rate of the reaction, this is the rate of the reaction, is this equation is called the rate of the reaction is directly proportional to the concentration of the participants. Now, this equation is called the rate law. Look at this rate of the reaction, proportionality when ended, K is equal to multiply. So, what 2 terms are important? One is the molecularity. What is the molecularity? Number So we are discussing the molecularity of the reaction, number of the participants, number of the reactant participating in the rate determining steps. Here is the only what is the rate determining step. Slow step is called as the rate determining step. Here is the single step, that is the rate determining step. So what are the participants? What are the participating reactants, nucleophile and substrates? So there are two participants on the behalf of the molecularity. So these are called as the the concentration of the rate of the reaction depends upon the both of the reactant, nucleophile and the substrate. That's why its name is SN2 reaction, because the rate of the reaction depends upon these two reactants, nucleophile and the substrate. This is clear. And second is the how do you write order of the reaction? Order of the reaction is the sum of the exponents of the concentration. For example, concentration of alkyl halide and nucleophile, that is the one of them is equal to 2. So order of the reaction is unity. It means 1 plus 1 is equal to 2. So we can say due to the molecularity and order of the reaction, chemical rate of the reaction is rate of the reaction, order of the reaction and molecularity is 2. On the behalf of this reaction is called as the SN2. One thing is cleared. Number second equation can be rate of the reaction is equal to K constant directly proportional to concentration of the alkyl halide and the nucleophile. Second most important step of this nucleophilic substitution reaction is the stereochemistry. Stereo of this chemistry. Configuration of the molecule. For example, if you look at this configuration of the molecule, there is a primary alkyl halide carbon has a sufficient space, sufficient room for the attack of the hydroxyl group. So bromide, you can say, look at this, you can say for example, this is the enough room. Here, there is enough room for the attack of the nucleophile. And for the, you can say here, nucleophile has sufficient space to attack on this carbon. Direction, if you can say, direction of the attack of attacking nucleophile is very important. It attacks from the side which is opposite to the label. It provides the sufficient room to attack the substrate, provides the sufficient room to attack the nucleophile. As a result of this, hybridization is also changed. This is the sp3 hybridization, and transition state is going to be sp2 and become the planar. So the molecules, which is when OH attacks on this side, the molecule is inverted. This is the 100% inversion. Inversion means this, if you look at this CH3 hydrogen and look at this CH3 hydrogen, they are totally inverted. Molecule after the attack of nucleophile is totally inverted and make a space of a nucleophile. So this is called as the inversion of configuration. 100% inversion of configuration takes place. 100% these three molecules are inverted. This is called as the stereochemistry. I think stereochemistry means inversion of during the reaction, configuration of the molecules get inverted. Here, these are the steps. So stereochemistry, chemical kinetics, these are discussed in the SN2 mechanism. Next is factors that affect the SN2 reactions. Of course, stereochemistry is very important. When the nucleophile attacks, the molecule is inverted. Substrate molecules are inverted. Their stereochemistry is totally changed. This is called as the inversion of configuration. Steric effect is also important. If there is 2 hydrogen 1 methyl group, if you have to replace it with the bulky groups, so this reaction is especially performed, SN2 performed by primary alkyl halide. So steric effect is also very important in this case. Next is the Now, next is the nucleophilic substitution reaction, SN1 reaction. SN1 reaction. What is the SN1 reaction? This is the, what are the basic steps? Before going, I'm going to tell you step. This is called as the unimolecular nucleophilic substitution reaction. It proceeds in 2 steps, and first of all, I'm going to tell you the step. First of all, these SN1 mechanism, tertiary alkyl halide follows the SN1 mechanism. First step is that ionization of the tertiary alkyl halide. First of all, it contains the 3 bulky groups CH3, CH3. So it is ionized in the presence of polar solvent and carbocation, just like that, carbocation, C plus is formed. This carbocation is very important. This is first of all. For example, here, hydrolysis of CX bond takes place. Here, this is the formation of carbocation. Here, when ionization takes place in the presence of the polar solvents, carbocation is formed, and bromide with the negative charge is separated out. So it follows the 2-step mechanism. Second step is that nucleophile easily attack on the carbocation. As a result of this, nucleophile replace the bromide and attached here. So what are the difference between the SN1 and SN2? First of all, why it is called the SN1 mechanism? There are 2-step mechanism. In first step, a bromide group is leaving out. So this is the slow step. So this is the rate determining step. So here the participant in the ionization of alkyl halide is only one tertiary alkyl halide. So that's why that is called as the, according to the kinetics, molecularity and order of the reaction, the participant or reactant in the rate determining step is only the alkyl halide. So this is called as the SN1. And this, in the second step, nucleophile attacks on the carbocation, stable carbocation, and forms the nucleophile. Nucleophile makes its space. Now, first is the stereochemistry I am going to discuss. Here, there is no question of direction because already carbocation, if you are looking at this, carbocation is a planar species. There is no question of the direction of attack. Does not. Intermediate carbocation is planar species. So it allows the nucleophile to attack both sides. Either the same side where the bromide group leave out or the backward direction. So there is a 50-50% chance of the configuration. If it attach on the same side or in the front of the carbocation from where the bromide leave out, then the molecule will be remain same. Molecule is not inverted, it will remain the same. This is called as the retention of the configuration. Configuration is going to be same. But if it attacks from the other side or backward side, then the molecule will be inverted. So you can say there is a 50% chance of remaining the same structure as before the attack of nucleophile. That is called as the retention of the configuration. And the 50% chance when it attacks from the other side, their molecule is inverted, changes side. So this is the first inversion of configuration. It forms a 50% retention of configuration and the 50% inversion of configuration. This is the stereochemistry. And rate of the reaction, I have told you, if you look at this, rate of the reaction this is another example. Rate of the reaction is always depends upon the slow step. So what is the slow step? Here, where the ionization takes place. So molecularity depends upon this reaction. As a result of this, You can see this is all about the nucleophilic substitution reaction SN2 and the SN1. If the question show the difference between the SN1 and the SN2 reaction, it's very easy. You can say SN2 is the single step reaction, SN1 is the two-step reaction. In this reaction, in the SN2, reaction kinetics depends upon the two molecules, nucleophile and the substrate. But in the SN1, the rate of the reaction depends upon the orochemical kinetics, depends upon only the first step, where the reactant is only the tertiary alkyl halide. Number third, stereochemistry. Here's the 100% in SN2, 100% inversion of the configuration takes place, but in the SN1, 50% inversion of configuration takes place and the 50% retention of configuration takes place. So, SN2 mostly follows by the primary alkyl halide and SN1 mostly follows the tertiary alkyl halide. Secondary alkyl halide sometimes follows the SN1 and sometimes follows the SN2 mechanism. Here I think these are all about the differences between the SN1 and SN2 reactions. Thank you so much.